Over the last few years, I have been testing rifle and handgun bullets in a test series that I call PAC-T. Now, PAC-T is precision, accuracy, consistency, and terminal performance. The precision part comes from a 5-shot group shot off of a rest, normally at 15 yards for handguns and normally at 50 to 100 yards for rifle rounds. I measure the extreme spread and oftentimes will calculate the MOA for rifle groups at least, and that becomes our precision measurement. From that same bullseye target, I will score it, and that becomes our accuracy assessment. And then our consistency, the C component, comes from the lab radar chronograph, or really any chronograph would do, but I'm looking at the standard deviation of the muzzle velocities. Now the T component comes from a terminal ballistic testing, and what I use for that is 20% NATO block of synthetic ballistic gelatin. And now that the weather's warming up, it's about time to get started with a new series of PAC-T tests. Now, temperature is actually very important to running these tests correctly, let's say. If you're using natural ballistic gelatin, then temperature becomes a tremendously important part where that ballistic gel block needs to be shot across a really tight range of temperatures. Really, probably to be done correctly, it should be done in a temperature-controlled environment, such as an indoor laboratory. That's one of the benefits of using synthetic ballistic gelatin, is that it can be shot at a variety or much wider range of temperatures, ambient air conditions. But what I have found is that if it gets too cold, then that gel block stiffens up too much, and if it gets too warm, it becomes a little bit too soft. So I'm making sure that I always fire these or test these bullets with this synthetic gel block at least 50 degrees ambient air temperatures up to about 85. We get too much into 90, that's a little bit too warm, and we start seeing that real softening effect. And then it's difficult to compare one bullet to another if it was shot at a much different temperature. Now, I get a lot of comments on these videos, and oftentimes very good comments, very good questions, but sometimes I get these comments that make it very clear to me that the person doesn't understand ballistic testing, probably doesn't understand scientific testing. What I hear is, oh, this other XYZ did their test with a 10% FBI block, or they didn't, or you didn't follow the FBI protocol, or this person did this and that person did that. Well, here's the deal. Couple of things to note about that. Number one is I specifically made an understanding ballistic testing video a number of years ago, and number one is take a look at that video so you'll understand ballistic testing. Number two, also understand that in a real-world scenario, nothing is ever perfect. And so it's actually really important to put a bullet through a variety of tests. Those 10% FBI blocks, very good to make use of those. Just as it is very good to make use of the 20% NATO-type blocks. Good to follow the FBI protocol, is good to follow a slightly different protocol that you might make up or someone else might make up. Because all these different scenarios are going to be important when we start pulling together all the results, and specifically if we're looking at one bullet. Maybe we're looking at evaluating the federal HST bullet that has done really, really well in our tests and under my protocol. If that same bullet does very, very well with a 10% FBI block in this person's test and that person's test, that gives you a very good idea that this is truly a reliable bullet. I'd also like to make note of what I consider sort of a disturbing trend recently. Ballistic gel block testing has become quite common and quite popular. And I think that the marketing folks have learned that, especially for pistol bullets, that a dramatic, very exciting looking ballistic gel block test helps them sell bullets. And the trend that I'm seeing is not so much the use of ballistic gelatin. There's nothing wrong with that. That's cool, fun to see at least. And if it's done well, it can be used for some really serious evaluation. But what I'm seeing, and what I think is somewhat disturbing, is that some of these ammunition manufacturers seem to be developing bullets and developing rounds just to pass the test. They're built for the test, not necessarily for that real-world performance. Now you might say, well, that's what the protocol is all about. It's supposed to be evaluating for the real-world situation. It's making a scenario. That's the same as real-world. Well, that's a big assumption. That's a really big assumption to make. And looking at the scientific literature on this, there is really not that great of a correlation between the ballistic gelatin tests, how dramatic it looked or whatever, and real-world scenarios. There are too many variables involved, too many factors involved to say that, okay, the bullet passed that particular test, therefore it's going to do great in the real world. Nope, too many factors involved. That's why we need to put these bullets through lots of different various tests. And let's not forget the fact that the shooter has to do his or her job and put that bullet in the right place if it's going to do its job. Now, with that out of the way, let's take a look at the bullets that we're going to be testing this year. We're going to be doing a lot of testing with 9mm bullets. I have recently picked up, and actually this was requested by one of our viewers. This is Liberty Ammunition Civil Defense. This is a 50 grain, 9mm plus P 50 grain bullet that's supposed to give us over 2,000 feet per second at the muzzle. I also recently picked up a G9 Defense. This is an 80 grain bullet for the 9mm again. Working again with the 9mm, we're going to take a look at these two bullets, Hornady Critical Duty, Hornady Critical Defense. Have some fun with those two. We're going to be looking at the last of our 9mm. This is a plain Jane box, isn't it? This is a really interesting and kind of a great lucky find for me. This is XM or M1153SP 147 grain jacketed hollow point reference ammunition. This is the top of the line, best stuff that Winchester is producing. And of course, Winchester is producing this round for our military. This is their reference test ammunition. So they make only so much of this stuff. And what they do is they make it to the tightest of tolerances possible, and then they retest a new batch of ammo against the reference. So I'm excited to try this one out as well in the future. Shifting gears, we are going to shoot a little bit more with the 45 ACP. I'll be using my HK45 Tactical for that. This is one of those HST bullets, 230 grain for the 45 ACP. Then we're also going to be shooting some more buckshot. Again, requested by some of our viewers. Maybe you had requested that. And it's going to be kind of a big episode. What we're going to do is we're going to look at a lot. We're going to look at a lot of double-aught buck. We're going to do a throwdown of the double-aught buck. Federal Power Shot, Barnes Defense, all double-aught buck. Similar to the Hornady Critical Defense, double-aught buck. Another one from Hornady, double-aught reduced recoil, American Gunner, Hornady Black, double-aught. And then it gets exciting. We're going to shoot some heavy shot, heavy duty, number 4 buckshot, and Federal Power Shock triple-aught buck. I'm going to do this test. That's going to be a fun one also coming up in the future. And we might end up shooting some more bullets, different bullets than what I've already laid out based on input from you, maybe some other ideas that I come up with. But today, we're going to use this. We're going to use this, the G9 Defense 9mm. I'm excited to give this a try, so let's head out to the range. See you out there. This is the G9 Defense 80 grain 9mm Luger rounds, not the Plus P. They do sell both of those. Supposed to give us 1,480 feet per second at the muzzle, so I'll be running this, shooting at a target, a bullseye target, 15 inches away. I've got my target cam running, and then we're going to switch over, and I will be shooting at that clear ballistic gel block, 20% NATO block from a distance of 7 yards. 1 round into that gel block. Well, let's go ahead and get all this started. Oh, couldn't get it. Darn it. Let's move it a little bit. Now that's interesting, 1,485 on shot number 2, and whoops. Remember, the stated on the box is 1,480 feet per second, so this is pretty good. Couldn't get that one. $1,516. That is round number 5. Very unfortunate. We only got 2 rounds. So, I really want to get 5 rounds chronographed. So I'm going to load and I'm going to shoot off target purposely. 1,395. Practice the trigger squeeze at least. 1,468. There seems to be a fair amount of variability in the velocities here. 1,384. We are clear. G9 Defense, 80 grain bullet into that gel block 7 yards away. I'm going to try to put this right in the center. Actually, I'm going to try to get it a little bit low to accommodate some other rounds I want to put into it later. Well, there's our bullet right there. It went pretty much where I wanted it to. I wanted it to go, as I said, a little bit below the center to accommodate some other bullets I want to shoot in here later on. It looks like it flipped completely around. Let's get a measure on this. We'll get the exact measurement back in the shop. We're at about, I would say 12 1/4. It looks like right there, about 12 1/4 inches. Thanks for sticking around for the wrap-up of this G9 Defense 80 grain 9mm bullet. Let's start off by looking at the precision, accuracy, and consistency results. Precision and accuracy, remember, comes from this bullseye target, and we had a 1.463 extreme spread. That's between these two rounds right here. That constitutes my extreme spread. Accuracy, obviously all 5 rounds were on target. That's a good thing. Shot these again from 15 yards, score of 37 points with 0 in the bullseye. Now I'll note that my HK-VP9 and that Trijicon optic I have on that are not. That's not zeroed for the G9 Defense round. So, one of the things that I'm changing up this year with our PAC-T test is we're going to look at we could say a simulated accuracy test, or rather an adjusted accuracy test, because if I did zero my pistol for this round, well then that would have all shifted down here. So what I'm doing, I have printed on this side here a overhead transparency, a clear transparency of the same target effectively. And what I'm doing is I will position this over the center of the group, and then I will be able to read the accuracy as if I had zeroed this round for that particular pistol. The end result is a perfect score of 50 points with 3 in the X. This round ended up with an average muzzle velocity of 1,450 feet per second, and the consistency comes from the standard deviation of those velocities, 57.7, essentially 58 feet per second standard deviation. Now, as a reloader and an extreme reloader into precision, that's terrible. That is really terrible standard deviation or consistency of those muzzle velocities. So get dinged a little bit right there. Another thing I was asked to look at and sometimes comment on is the recoil, felt recoil of these different rounds that I'm testing. So this is another thing that I'm doing this year. I shot 5 more rounds with the G9 from an offhand position using the Mantis X10 in recoil meter mode. And I'm going to be doing that for all of the rounds that we're going to be testing this year. And I also tested what I'm calling a standard. Okay, so I'm setting a standard for 9mm recoil with this particular VP9. And my average, I should say my standard ammo is a 115 grain CCI Blazer Brass 9mm. Kind of your plain Jane, full metal jacket, just your plain Jane normal ammo. Probably many of you have shot that. That's why I'm using that. You have something to compare against. So we're going to be looking at average recovery time and average muzzle rise. As you can see here, the standard ammo gave me a recovery time of just over 1 millisecond, 1.09 milliseconds average recovery time. The G9, 0.91 milliseconds average recovery time. Average muzzle rise, only 16.5 degree average muzzle rise compared to almost 19, effectively 19 degrees for our standard ammo. That doesn't surprise me though, doesn't really surprise me at all. And that is because this is an 80 grain bullet compared to that 115 grain bullet. And we tend to perceive more recoil with the heavier bullets that we're shooting. And if we're later on testing, the 115s, 124s, 135, 140s, whatever, we're going to probably see some of those rounds exceed our standard. But in this case, it's a more shootable round compared to or contrasted with the standard 115 round nose. Well, now let's go ahead and dig into the terminal performance results. Penetration was 12¼ inches. That's the official measurement I got when I dug into that gel block when I got home here. Retained weight, full 100%. Actually, officially, it's 101%. Of course, I didn't weigh the bullet before I shot it, so it might have been just that little bit heavier. Perfect weight retention nonetheless. Retained length, that was pretty good. Also 0.538 inches. Expansion, 100%. And an overall score of 272.5 points out of a maximum total 500 points. We haven't seen any bullet get 500 points or even 490 points. But if we get a bullet that moves into the 400s, and we've seen that with some of our better bullets, those are the top-notch bullets, 400 on up. Now, one of the reasons I think that this bullet did not score really well is it scored against very closely, I call it a modified FBI scoring protocol. Modified for a couple of reasons. Number one, I'm using the 20% NATO gel block, and so for that reason I had to make some modifications and scale some of their results and scoring to fit this. So one of the reasons why that I think it didn't score really well was because of that expansion. It didn't expand, right? It did not expand, so that whole portion of the overall scoring from expansion was more or less zeroed out. No extra points for good expansion. But this G9 is supposed to produce a hydraulic effect, transient cavitation inside the gel block, but we really didn't see that. We did not see this very large, kind of dramatic looking balloon effect happen inside that gel block. So I'm not so sure it really is or would be that effective of a round. When push comes to shove, let's say, would I use this bullet for my everyday carry, for my home defense? Well, if I had nothing else, sure. But I have something else. I've got a lot of really good bullets available to me. I've got that top of the line, I would call it one of the top of the line bullets, that Corbon 115 grain DPX bullet. I've got the Federal HST 124 grain bullet, and plenty of those. So I won't be choosing to carry this particular bullet. I'll go ahead and shoot these kind of for the fun of it, I suppose. A little bit of practice, and that will be that. Well, that wraps up our PAC-T test of the G9 Defense 9mm bullet. If you'd like to see one of the bullets that we talked about early in this video, let me know. Put that into the comments. I'd like to see whatever. Which one of those would you like to see next? I'll see if I can juggle around the schedule and get that popped in to be our next PAC-T test video that we release. Thanks a bunch for watching. See you in the next video.